Good morning, children. Today we will continue the chapter friction, in which in the last session we discussed about the definition of friction and the role of friction. Now we'll discuss further that friction exists on what surfaces. Friction exists in all the surfaces. Whatever the surfaces which we are seeing in our surrounding, on all the surfaces friction exists. We cannot find a surface which has no friction, but we can find the friction on all the surfaces is different. In one surface the friction is greater, on the other surface the friction is smaller. That depends that the amount of friction, the extent of friction, which depends on some factors. Now we have the surfaces. Suppose if I take this board, we see the board is plain and it looks like it is very smooth. But if we see the board microscopically, then on the surfaces we see the surface is not smooth. We observe there are so many ups and downs on the surface. Due to that ups and downs, in other words, we can say the irregularities on the surface. Due to the presence of irregularities on any surface, the friction arises. The irregularities, the ups and downs, suppose if we take any surface, on the surface there are so many ups and downs, irregularities. The extent of irregularities is different in different surfaces. If the irregularities is more, then the surface is rough, is known as rough surface. If irregularities is less in number, then we say the surface is comparatively it is less rough. We cannot say it is completely smooth, it is less rough. It is also having roughness, but compared to the surface this is less rough. Now the friction depends on this roughness of surface. If a surface is rougher, more rough, then it has greater friction. If a surface is less rough, then smaller friction. So the friction greater or smaller, which depends on the roughness of the surfaces. If we take in our daily life example, this board, it is having some roughness. Then the floor, it is having some roughness. But the roughness of this board and the floor are not same. That is different. They are different. Then if we take a table, horizontal table. On the horizontal table there are some roughness. If this table is polished with some oil, then the roughness changes. Definitely the roughness decreases. So simply the horizontal table having some roughness, when we polish this table with oil, the roughness decreases. So that decreasing of roughness is due to the oil. It reduces the roughness. Then the friction also reduces. How can we find the friction reduces according to the roughness? For that we can take the example. And this example is related to a table. It is the table, horizontal table. On the horizontal table, we put a small ball and the ball is pushed with some force. Then what happens? The ball moves. The ball moves. The ball moves for some distance and then come to rest. It is due to the friction between the ball and the table. Now in the second case, on the same horizontal table, we polish that table with oil, that oil surface. Again the same ball is pushed with the same force. The force applied is same in both the cases. Here also the ball moves. But now we find the ball travels over the longer distance than the first case. Then take the third one. On the same table, now we spread a polythene. Spreading a polythene, again the ball is pushed with the same force. Now also the ball moves through some distance and come to rest. In this case, the distance covered is different in the earlier two cases. Then coming to fourth case. On the same table, the newspaper is spread. Newspaper. Again the same ball is moved and it travels. Then it comes to rest for some distance. In all the four cases, we observe that the distance covered by the same ball for the same force is different. It is because the friction on all the four surfaces is different. Here, in one case, the distance covered is maximum, and that is the surface having less friction, because as the ball is moving, the surface is continuously opposing its motion due to friction. It is able to travel over the longer distance. It is because less force is opposing. That's why we say, in this case, least friction. So if the friction is least, the ball is able to travel over the longer distance. Then if we see in the first case, the distance traveled is minimum. The minimum distance traveled by the ball due to the more opposing force, that is maximum friction, more friction. So finally we can conclude that if the friction is least, it is able to travel through the longer distance. Friction is more, then the distance covered is less. So this is one example from where we find the polished surface. Here the oil, it is having more polished surface where the friction is least. If it is more rough, the friction is more. So rough surfaces having greater friction or polished surface having least friction. Now we'll see that how does this friction arise? How this surface is opposing the motion? It is because of irregularities present on the surfaces. Then how these irregularities oppose the motion of ball? That explanation we'll see in the next video.